few words about the two projects that are organizing this online event, this webinar. So many of you are probably familiar with the project, but it's always good to remind about these two key STEM education projects. So Scientix promotes and supports a Europe-wide collaboration among STEM teachers, education researchers, policymakers, and other STEM education professionals. Scientix was launched in 2009, and we are now in the third stage of the project that started in 2016. And the initiative is funded by the Horizon 2020 program of the European Union for Research and Innovation. So if you want to find out more about the various activity and resources that Scientix is providing and the events, you can go to the Scientix portal, scientix.eu. You can contact either the Scientix national contact points of your country or the Scientix central office at European Schoolnet. You will find all this information on the Scientix portal. Which brings me now to the second initiative that you can see on this slide. The STEM Alliance brings together industries, ministries of education, and education actors to promote STEM, so science, technology, engineering, and math education, but also STEM careers to young Europeans. And the aim of this project is to address a major challenge in Europe, is the future skills gap that we can expect in the European Union. Basically, the idea is to raise the interest of young people for STEM education and STEM career. So the aim is to increase the links between STEM education and careers by involving schools throughout Europe. And with the support of major industries and private partners that you can see here, the STEM Alliance promotes STEM jobs in all industrial sectors and contribute to build a STEM skilled workforce. So without any further delay, I'm moving on to the social media of these two initiatives. So if you want to find out about the latest activities in STEM education in Europe, in Scientix and in STEM Alliance, we welcome you to follow us on Twitter, Facebook, Instagram, and YouTube. You can see the details on this slide, and you are also very welcome to share your own activities using the hashtag and the account, tagging us with the account that you can see here. I hope that many of you, I see 143 attendees for this webinar. That's amazing. We're really happy. And I'm sure that many of you are aware that the STEM Discovery Week is coming up very soon. So next Monday it will start. So the idea was to have April as a STEM month. So I know that a lot of you and many more have organized some activities already, but we expect a peak of activity from the 23rd to the 29th of April. So you can see that, so I'm happy to inform you that we have now published more than 500 activities, 539 to be very specific, in 34 countries as part of the STEM Discovery campaign. We have therefore reached the goal we had set for the campaign, which was to publish at least 500 activities in STEM education that are organized as part of this campaign. There are 21 projects, 37 organizations, and 32 schools confirmed as official partner of the STEM Discovery Week, and more partners are joining us every week, so this number might change still next week. So please note that anyone can still upload activities to the map, and we would of course like to see as many of this activity as possible before we kick off on Monday 23rd of April. So you still have time until the end of this week, and you will also be able to do it next week. So next week during the STEM Discovery Week, we will connect live via video to selected activities happening in different countries in Europe. And we have published a provisional calendar on the Scientix website with the scheduled video streams. So we invite you to visit You will find this activity on both Scientix and STEM Alliance website. From the home page, you will find directly the relevant links. So we are really looking forward to celebrate STEM education and STEM career with you next week. And we encourage you to keep sharing the word about the STEM Discovery Week using the hashtag STEM, so hashtag STEM Discovery Week, everything together. So now moving on to our webinar of today. So I'm really glad to introduce you to our speaker of today, Gergely Nadori. He's a Scientix ambassador in Hungary and is also a Microsoft expert educator and a science teacher in a secondary school in Budapest. He's the editor of the most popular education blog in his country, called tanarblog.eu, that has more than 20,000 visitors per month. So Gergely is really active because he also has published 3 books on the use of ICT in STEM education and is organizing in-service teacher training on this topic. He has already been the presenter of 3 other Scientix webinars, so that's not a beginner here. And so now I'm going to leave you the floor, Gergely, and you can go ahead, start your presentation.
Thank you. I hope that you can hear me as well.
Yes, really well. Thank you. Go ahead.
You do. Okay. Then I will even try to connect my camera as well, and then start to share my screen.
Okay. Just to say that the slides were in the same presentation. That's
yeah, but I plan to
okay.
Go around and use some other things as well.
Good.
So I need to switch between different things. I hope that you can see now what I'm showing.
Yes, we can. Thank you.
You can. Okay. So what I would like to talk about are the hacking STEM projects, which can be used for inquiry-based science teaching and learning. And what I would like to start with is that if there were commandments of science teaching, then probably the first of those, or among the first, would be that thou shalt experiment, and you should use experiments in your science teaching. But it's not always that easy how to do that and what kind of equipment use that for how to design your experiments so the teaching value of them would be the maximum. There are a lot of devices that you can buy which can help you with experiments, a lot of data loggers, different types with different sensors. My experience with them is a bit mixed. First of all, they are quite costly, and I have this experience that most of them are good for quite special uses, for special types of experiments. Each has their own software that you should learn to use them, and so on and so on. And another big problem with these devices is, according to my experience, is that the students use them as a kind of black boxes. You know that the black box in science is something that you know what it goes in and you know what comes out. You know the input and the output, but you have no idea what happens inside the thing. And all these very, very advanced devices work in this way. You put them somewhere, they show some numbers, and then you can calculate with those numbers, but really what's happening you cannot be sure of. I don't have this feeling that they always help students understand what they are doing when they are using them. And a lot of times I'm reminded of this law of Arthur C. Clarke, the science fiction writer who said once that any sufficiently advanced technology is indistinguishable from magic. And I have this feeling sometimes that these very, very advanced devices that students sometimes use in science classes are just magic to them. They don't really understand what's happening. They just know that you put it somewhere and then it shows some number and that's it. So the alternative that I found very, very fruitful in using in my teaching is the hacking STEM lessons and activities, which are designed by a dedicated team connected to Microsoft, a team of teachers and researchers and designers who plan to make science activities which can be used for inquiry-based science, but which help deep understanding for the students. You can see their web address. We will visit that soon and we will see what you can find there. But first, some of the basics that all these activities are based on, built on. The first of those is an add-in to Excel. I guess everybody knows Excel, which you can use to visualize data or to calculate with data. It's part of the Office programs. And this add-in, which is titled Project Cordoba, as you can see there, can be used to get in data from the serial port. So you can connect any kind of device through the serial port, and the data that is coming in, the serial port in this case means the USB actually. The data which comes in is used by the Excel real time, so you can use it immediately. And the second thing that all these projects are based on or built on are microcontrollers. Most of the times what they are using are the Arduino microcontrollers. These devices are not full-fledged computers, so they are not microcomputers because they can only run one program that you upload on them, but they have a lot of inputs and outputs, digital, analog, and you can use them to connect sensors to it, or even to use them to connect to other devices. Arduinos are quite cheap, so you can buy them really cheap because they are open source, so anyone can make their own Arduinos. If you look around at eBay or at AliExpress, then you can find real bargains for the Arduinos. And the third part are very cheap, very easy to get materials and things. What I had a picture of here is the glue gun, which is the most used device in all these projects. You always have to have your glue gun at hand, but plastic straws or small magnets or copper tape are the things that you will be using to build your instrument. And even the ones which are not that easy to get, like the copper tape or sometimes the reed switch or things like that, you can get for cents at eBay or at AliExpress or at these auction sites. And if you plan ahead and you are ready to wait for a month for it to arrive, then you can start working without a big investment. One of the other things that I like a lot in this approach is that the things that the students are building, or these instruments that they are building, are really cheap, and you don't have to worry of them that they will break them, because when you are using LEDs and they cost less than a cent, then, for instance, if they put it in the wrong direction in the circuit, so what? One of them is dead, but you can have a fistful for $1. So it's very easy to work with them, and you can give it to the students to use them and break them if that happens. Also, it's my experience that they don't break them so often. So if we go on the website, and we will do that soon, you can see that there are these 9 activities right now there. We will look at them one by one quickly, and I will tell what they can be used for and how they work. And I made this table to show you which one of those are connected to which subjects. Most of them use a real complex approach to science. So as they are mainly built around the problem and not around a subject, of course, they touch a lot of different areas at the same time. Like when you are building a robotic hand, I could also put there physics, because you are also using that in calculating how much to move and how to move, or and not just biology and so on. So you can use it for a lot of them, but these are mainly the ones that the subjects that are covered by the different projects. The age group that they are aiming at is middle school. So in a classic school system, that would be from 5th to 8th grade. But according to my experience, you can use it even with older ones. You can improve on them, or you can go a bit further than they usually do. So you can use the project, most of the projects with older students as well. But they are very well designed for this age group. So let's have a look around at the website. What can you see there? So if you go on the website, that's what you see, and I would really appreciate some feedback that the website is seen right now. Are they, or is it? Okay, perfect. Thank you. The address, I put it quickly here. Thanks. Then I continue. So this is how the site looks like. And if you go down here you see the lesson plans one by one. And if you go check one of them, like I do it here, then you can see that each of these comes together with basics. It tells you how much time you would need and how much it would cost to you. And you get a OneNote notebook, which gives all the data, all the files, everything together. But you can also find it here here is a PDF of the instructions, which are step-by-step instructions for the students to follow, and also for the teachers to see what is happening. You will have an Excel workbook where you will use the data coming in and visualize it and interpret it. You have a materials list, kind of a shopping list, what you need to buy, and you have the code that you will upload to the Arduino, to the microcontroller to use. And let it be the first one that we check on. I hope to show you, yeah, here. Yes, I will try to show it. I hope that the camera shows it. This is the device that you build with this thing. It's a big straw. Inside you have two wires. It's closed with a glue gun, and you can use it to measure the electric conductivity of solutions. And how the lesson is built, if we look at it, and this is one of the things that I like a lot in these lessons, that they are step-by-step lessons, kind of a modular lessons. You can use only parts of them if you want to. Oh. Okay, then I will try to share it again. Just a moment. Ah, yeah, that's what you should see. Okay. Yeah, I guess that it takes a bit of time. So let me wait for it to download. It first starts with simply having a cup of distilled water, and you put two copper tapes in it and connect it to a battery and an LED, and you start to put in salt and see when the LED lights up. And then you realize, or the students realize, that the conductivity of water is connected to the amount of salt in it. Then the next step is that you build this device that can be used to measure conductivity. You connect it to the Arduino. You calibrate it. I also like a lot in this that the students learn the basics of calibration, that you need to calibrate your devices when you are using them. You calibrate it, and then you can measure the conductivity of different samples, and you can even think about what can cause the differences between them. It can be the difference between how polluted the water is. The next one that I would like to show you is also a very simple one. It can be used for the teaching of kinetics, for the teaching of movement, speed, acceleration, and so on. Usually when you are doing it, if you are trying to buy some equipment for that, then you use light gates, which are fine. But I liked a lot here is that they use a much simpler solution. The thing is that you use a Hot Wheels track. In every class, there should be at least one boy who has one. Usually, most of the boys have one. And you build these gates, and I don't know if the camera or the webcam shows it or not, but these gates have just two naked wires hanging from it. And what you do is that you glue, again using your glue gun, a bit of wire on the top of the car, and as it runs through here, it connects the two wires, so closes the circuit, and the Arduino can register the time when that happened. And if you have two of these little gates and you know the distance between them, then you can calculate the speed of the car. If you have three of these, then you can calculate the acceleration of the car. Even if you go further, you can use a special plastic where the resistance is dependent on how stretched it is, and you can use that to measure the force with which the car is hitting the end of the track. I used this, I built this with my students, and I used this for them to calculate the speed that you need to go through this loop-the-loop, that how much your speed need to be to do that, which is quite a complex thing. And I liked it very much that that they can build it from this very simple idea of simply connecting the circuit and registering the time of that. Okay, the next one that I would like to show you, and even if we can show in action, is this one where you are building your little Morse machine. Again, what you are using is a simple clip, wooden clip, that will be your switch, and from a magnet and a coil you build a speaker, so it can make some sound and even some light. Okay, the sound is not that strong, but I hope that you can hear it. So this is how you are making it, and here I show you how it works. So this is how it works. I go to Project Cordoba here on the Excel. I hope you can see it right now.
Yes, we can.
You can, okay, perfect. And you connect your device. Here is my Arduino. So I connect the Arduino. Yeah. I say that I would like to start the data. And now there are two things that I can do. I can send out a message, for instance, let it be Scientix, and if I send it out, that I will hear the beep and also the LED is blinking as the message goes out. And the other thing is that I can even send a message and try to decode it. I'm not really good at it, but I will try to do something like here. Okay. Okay, I could send an SOS message here with my little Morse device. And here again, this is a nice modular thing, because first you just build the switch from the wooden clip with an LED and the battery, and you learn how it works. Then you build the coil and see that when you close the circuit, then it gets magnetic. And then you build the speaker, and you see that when you close the circuit, then you hear a little sound, and then you connect the whole thing to the Arduino and make your Morse machine of that, and it works well. You can also see here that what else can be done with the project Cordoba. You can even record the data that is coming into a file. And if you have a data file, you can even use that. If you don't have an Arduino connected, you can have your data and then see how it works. So that is also a solution if you don't have anything there. And what is also nice is that you can look into how the Excel works. Here, the encoder is explained how it works, and then you can see the data coming in, how it came in. You can see what is the data that is sent out, and here you have the settings that you can change. Also, with the Arduino programs that you flash onto the Arduino, you can look at them and see how they work. They are really well commented. So if you or one of your students are interested in tweaking them, looking into them, then they can do that. And that is again something that I like a lot. That all these devices that you build are not the black boxes that I talked of before. Rather, they are something that you can understand how they work. What is important is that none of these devices will be very, very accurate. None of these devices can be used to measure something very, very clearly. But they are very good for showing principles. And I think that this way they help understanding much better than a professional device would do. Okay, then. So the next lesson that you can find here on the Hacking STEM site is the seismograph. With the seismograph, you are also using induction, magnetic induction. You have a coil and you have a little magnet above it, and its movement is registered as electric current, and you can see how it works. But also this project goes further, and what you can build here is the mass damper. I don't know how familiar you are with the Type 101. It was, I guess, I'm not sure, it was the tallest building on Earth at the time it was built. And it is in Taipei, which is very vulnerable to earthquakes. So somehow they had to protect it from earthquakes. And what they did is that there is a big sphere, some 60 tons or around that, hanging in the middle of it. So whenever the tower would move, it dampens the movement of the tower. And you can build a model of that using simple wooden straws and paper plate and washers to do that. And on the top of it, there is, it's an alternative to Arduino. It's called Adafruit, which has some sensors already built on the board. It has accelerometers, so you can use them to measure the acceleration, how much this dampening effect works. And you can connect it to this real-life example of the Taipei 101 building. Okay, the next one is going here. Among the earlier ones, you can build your own wind turbine. Here you see this plate is rotating with the magnets on it, and there are the coils, so you can generate current, and you can even experiment with different types of propellers, which is the most effective. The anemometer uses a different approach. It has a reed switch in it, and a little magnet is connected to one of these rods, and every time it goes above the reed switch, it registers it and can calculate the speed of the rotation, and from that you can calculate the speed of the wind. So that's how you can build an anemometer. Here, again, what you see is that you start with a simple project, first building just this anemometer, then connecting it to the reed switch, and then the next part is that you can build another propeller which is connected to a small Lego motor, and here you look at different points on Earth, and it gets real-time data about the speed of the wind there and rotates it as fast as it would rotate if it were there, for instance, in Seoul or in Seattle, and you can look at that. Then one of the most complex projects that you can find here are these robotic hands that you can put together. This project uses little servo motors. I'm using the 9G servos, which are really, really cheap ones. And you are making the arm from straws originally. First you see how it moves, how the different bones are connected and how they move a finger like this. You build a whole hand moving with small motors connected to it. And then you build this sensorized glove, which has the same material that I already mentioned with the Hot Wheels project, and which can kind of measure how it is stretched. So it can measure how much you flex your fingers, and if you connect it through the Arduino to the servo motors, then you can get your robotic arm to move the same that your hand is moving. And at the most complex part of this activity is where you can play rock, paper, scissors using this glove, and it recognizes what you show, and then even builds statistics based on how you are how much you are showing the rock or the paper or the scissors. So it starts with biology, has some physics in it, ends in statistics together. And one of the teachers who came up with this whole project showed us when I had the luck of talking to him, that his student realized that this same system can be used to move a puppet. So they built a dragon, and the dragon is moving based on the movements of your hand, which is really, really nice that the students develop further the idea that you have. And the last one that you can find now among the projects is this one, where you are making maps and designing the best route on a protected island. And for that you are measuring distances and angles, and from that for the measurements you are using the Pythagorean theorem. So here they start with measurement, and then it is turned into mathematics. So this one is mainly for maths, but also there are a lot of geography in it, or even ecology, about how to protect the best this island. And you can even put on different things on your island using the 3D paint, making it a real natural reservation. So this is the last one. This uses this meter, rotation meter, and I guess that is the most costly part of equipment that I've seen so far in this among the hacking STEM projects. So yeah, I would like to get back and continue with something that you might find also interesting, is that if you have this project Cordoba, you have all these tools together, you have an Arduino, then you can really make your own instruments as well. And here is one that I made for chemistry. I hope to show it to you here. And can you see it here now, this sway that I'm showing? No. Oh, okay. Okay, then you should in a couple of minutes. It shows that I'm okay. You can't see. Okay, so this device that I built, it's much simpler than anything that is on the hacking STEM site. It's not. I just showing it so you can see that even a humble biology teacher like I am can make things and build things. So. Um uh, what I did is that I used an optoresistor, the resistance of which depends on the light coming in, and what I did is that I have this beaker where there are two solutions mixed. The solutions make precipitation, so it's a precipitation reaction. So it clouds and the light coming at the bottom is getting less and less as the reaction goes on. And from the light getting in or how cloudy it gets, you can calculate how fast the reaction is going. So what I needed for that is that this is the circuit that I built. Here you can see a schematic of that. This is oh yeah, okay, just one moment.
So just a little comment, Gurley. It seems that some of the attendees of the webinar maybe have slower internet connection, so they cannot see the image.
I
So
just put in the link of the sway that
thank you.
I'm using. So okay, so this is the circuit that I'm making. I've put in a switch so I can start the measurement when I put together the solutions. And there are two resistors and the optoresistor. That's all. We have a 3D printer here at the school, so I printed this code for the thing, so no light is coming in from the sides, only from the top, and you can even find the design here on Thingiverse. If you want to print.
Just that it will be time soon to wrap up your presentation because we would like to leave some time for question and answers. Okay?
Sorry, I did not get that.
It's time to wrap up soon the presentation because we would like to move on to question and answers.
Oh, so we should end the presentation now.
As soon as you can, yes. So we can answer.
It will be really fast. Okay, just two more things. Okay, and here is what you can measure with that. This is sodium thiosulfate and hydrochloric acids together, and you can see how the light is getting less and less. And from it, you can calculate the speed of the reaction, and from that you can experiment with different things, temperature or the concentration, how it affects it. So that's something that I made and used myself. And now we are really getting to the very end of it. I just wanted to show that there are some more things on the site that you can use. There are the master skill guides for certain things that you use a lot, making coils or making these stretch sensors, and some little small activities which are really fun that you can also find there. And there is a LinkedIn group of Hacking STEM educators where already more than 300 educators are talking about these projects and ideas. And I thank you for your attention.
Many thanks for this very interesting presentation. I think you provided a lot of very nice ideas to implement some inquiry-based STEM education. And actually, I would like to share some of the questions we had in the chat during your presentation. And I will ask my colleague to put back the PowerPoint presentation. That would be great. And I know that you have a colleague also connected to the...
Yeah, there are some people here who are who among the ones who designed all these projects. So probably they will be much better in answering your questions than I would be, but I will do my best to answer them.
So I hope you can hear me well, because apparently the sound was not so amazing before. So here is the first question. So one of the teachers would like to ask if they can use some of this activity in primary school, so 6 to 12 years old students.
Yeah, I think there are a lot that you can tweak to them, and I am sure that even building the anemometer or even building the Morse Machine, a lot you can use. Yes, there are lesson plans, very detailed lesson plans connected to all of the materials.
Okay. Thank you. So the next question was how much time do you spend to do these activities with your classes? I have only 2 to 3 times 50 minutes modules a week of math and 2 modules a week of physics.
Well, it depends. As I said that these activities are quite modular, so you can use only part of them if you want to. You don't have to use all of them. To go through them, for instance, for the Morse ones, I used 3 50-minute classes with the students. And for the conductivity, I think even less. That was about 250 or 250-minute classes. We used it, and it worked well. Again, for maths, there are, for instance, the as I have shown, the cartography one, where you are using the Pythagorean theorem, and you can use the robotic arm to go into statistics a bit, and you can also use the a lot to calculations, like with the anemometer, how the diameter and the circumference are connected, and so on and so on. For the preschool recommendation, I think these activities are aimed for middle school, but I would advise you to look at them because they can give you a very good idea of the maker approach that they are using to science teaching. I see here that
I'm going to continue because we have some more questions.
Oh, yeah,
basically.
okay.
It'd be great if you could, yeah. So we had some comments from several teachers that were maybe a bit more skeptical about using some Microsoft material. So, for example, related to the costs, the cost of the experiment per student is $2 to $5 per student. It means an average of $70 for classes of 20 students, and it takes 1 to 2 weeks of classroom time. So, just wanted to give your opinion about that.
Oh, I could not get it. It was so I couldn't get it. I could not hear you well.
The cost and the time that this activity takes, some teachers were a bit skeptical about the amount of money that it represents and the time that it takes to implement in school. So what is your opinion about that?
Well, I think it depends on what are your goals or what you want to reach. If you want your students to really use an inquiry-based approach science, then it takes time, and I think there is no other way for doing that. So, and for the cost, I think that of any kind of things that I have seen so far, these are the most cost-effective projects that I've seen. If you are buying the Arduino, you can reuse it again and again, and otherwise you are using little pieces of wood and plastic. There is another question that came in, and I would like to answer that, is how the kids are coping with programming the Arduino. They don't have to program the Arduino. You can download the program and you can flash it on your Arduino, and you can modify it if you want to, but you don't have to. It works fine. So what the students are really building, they are building the instruments that they are making the measurements with, the devices themselves, and they are not required to build or to write programs in Arduino. They can if they want to, but they don't have to.
Okay. So basically, that's another question related to the previous one, if there are some cheaper alternatives for this kind of material on the market.
Cheaper than what?
Than what you mentioned.
Well, I don't know. I don't know if anything can be cheaper than that. So
Okay.
you can buy an Arduino for $4.
Okay. It's just one of the questions that was asked several times, so I want to mention.
So an Arduino board on AliExpress is $4. Okay. So I really can't see how you can go cheaper than that.
Okay, so we had some additional question. So we had it was more comment. So a colleague that is implementing such STEM activities for underprivileged kids education, providing free of cost education. So it means that it benefits to different type of community as well. And then we had a question about what about math focus activities? You have some recommendation about that?
Oh, I did not get it. It keeps getting lost, your voice. I got it that I should have an opinion about something, but I don't know what it is.
Math focus activities.
Math activities. I said that for math, the one with the Pythagorean theorem is really handy. The robotic arm can be used to teaching statistics, and a lot of them you can use to teach about maths. Like with the anemometer, you can use it to teach about the circumference of the circle. And there was also another question here where I am teaching. I am teaching from the 7th grade up to 12th, but I'm using these materials with the 7th, 8th, and 9th grade students.
Hi Gergely, it's Anastasia speaking. So my tech is experiencing some troubles with her microphone. I'm apologizing for this. And so it was more a comment from one of the participants that he is implementing STEM activities for unprivileged kids and for education, providing free of cost STEM education. So I think it goes in line with what you said, that the material is quite cheap and it can be substituted with even free material that you can find at home, yeah, like plastic and wood. Yeah. So thanks for your comments. And I don't see any questions at all. Maybe you can have a final word if you would like to. I see that there is a colleague of yours, most probably, supporting you in the chat. Thanks for this. He was I'm hoping that he replied to those questions which we didn't cover. And so we are about to close this session. First of all, thank you, Gergely, and thank you all for participating. And to update you on the next webinar, which will happen on the 26th of April at 5 sharp Brussels time. It will be again joint Scientix and STEM Alliance webinar about how companies can help schools to promote girls in STEM. So it's a hot topic for everyone. I hope you will enjoy this webinar and also the next webinars of Scientix and STEM Alliance. You can, after this session, we will send a follow-up email with the recording, with the link to the recording of this session. You can re-watch it again to see all the resources which were shared and maybe to find some more tips in the internet. And if Gergely allows, I will share the presentation with the participants as well.
Do that.
Okay, good. And we will follow up with you soon. Keep in touch and please visit websites of STEM Alliance and Scientix to have more updates on the activities we have for STEM education. Thanks for participating, and special thanks to Gergely for his great presentation, for a nice question and answer session. And see you next time. Thanks, that's it from us.
Thank you very much for your
Thank
attention.
you.
Bye.
Bye-bye.